Alright, wonderful welcome to you guys. This is Gallant Tutorial Academy. You're welcome. So nice having you guys here. If you are new to this channel, you can kindly hit the subscription button and click on the notification bell so that whenever we drop amazing and explicit content as this, you can always be notified. Alright, so quickly, today's short clip we'll just be discussing gas laws. So gas laws and measurements. So the main thing, there are some key concepts that or key standards that you are meant to take note whenever we are taking measurements of gases. These are one of them are some of the volumetric standards, as we have here, that we have that 1000 centimeter cube is equal to 1 liter, and that 1 dm cube is equal to 1 liter also, and that 1000 milliliter is equal to 1 liter. So if I'm just having that as one, it's just as me having it this way, that is 1000, then milli means times 10 raised to the power of minus 3. So this cancels this, which may have 1 liter. So that's that. Then also for the pressure, we also have some pressure standards which are very important. We have that 1 atmosphere is equal to 760 millimeter mercury. The same 1 atmosphere equals 760 torr, which is also equal to 101.325 Pascal. This is PA, which is Pascal. And we also have 101.325 Newton per meter square, Newton per square meter. So it simply means that 101.325 Pascal equals 101.325 Newton per square meters. So that's that. So it simply means that 1 Pascal equals what? 1 Newton per square meters. And we also have that 1 millimeter mercury equals 1 torr. And also we have here that 1 atmosphere, which is 1 atm, equals 1 bar. So those are pressure standards that are very important. Pressure and volume standards that are very important for measurements when we are talking about gas laws, so that you don't make the wrong conversions when they need be. Alright, so there are several gas laws that we have. We have different gas laws that were proposed by so many scientists. One of them that we have Charles law. We have the Charles law. So we also have the Boyle's law. Then we also have the Dalton's law of partial pressures. We also have the Graham's law of diffusion. We also have so many. We have Gay-Lussac's law. Of combining volumes. And the last year we have Avogadros Law. Yeah, it's also called Avogadros hypothesis. So these are the basic gas laws that we have, but for this video we will be dwelling more on the Avogadros law and the Gay-Lussac's law of combining volumes. The Avogadros law and Gay-Lussac's law of combining volumes. Alright, so one major thing you are also meant to take note is that whenever we are discussing gas laws, we are talking about relationship between quantities like pressure, volume, relationship between the temperature also, and the number of moles. The number of moles. So these are four quantities are very what we are relating when we are dealing with gas laws. So it means that all the gas laws are definitely talking about relationship between any two of these four, or more than two of these four. All right, so quickly let's look at our subject for today, which is the Avogadros law, Avogadros hypothesis. So basically, the Avogadros law was proposed by an Italian scientist, just in case you don't know, proposed by an Italian scientist, and it states that equal volumes of states that equal volume of all gases at the same temperature and pressure contain equal number of molecules, contain equal number of molecules. So the Avogadros law states that equal volumes of all gases at the same temperature and pressure contain equal number of molecules. So it means that the temperature and pressure are constant. That means it does not change all through. It does not change. So basically this this law, which is the Avogadros law, always relating the volume and the number of moles. So it simply means that the volume is directly proportional to the number of moles, as long as we have that our T and P are constant. As long as we have that our temperature and pressure are constant, the volume is directly proportional to the number of moles for that gas. Now, this law is used most times to give an assumption or to predict the empirical formula of gases. So let's take an example. Let's say we have an example here now. We have that okay, make a new page. So we have an example that one volume of hydrogen combines with one volume of chlorine. So we have that one volume of hydrogen combines with one volume of chlorine to give two volumes of hydrogen chloride. And so now we are asked to with this we are asked to predict the empirical formula from this. So let's say we are asked to predict the empirical formula, predict the empirical formula of our product, which is what? Hydrogen chloride. So we are asked to predict the empirical formula. Now, how do we do this? Using the Avogadros Law, which is a concept that was stated that equal numbers of equal volume of gases, as long as the temperature and pressure are constant, will have the same or equal number of molecules, or you can say equal number of moles. So simply we are going to apply this rule right now. So now, as we heard earlier, we know that one molecule of hydrogen, now we are the question said one volume, right? One volume of what? Hydrogen. So it simply means that since we have one volume and the temperature and pressure is constant, it simply means that we will have what? It is the same as us having one molecule of what? One molecule of hydrogen. As the law implies, equal volumes of gases at same temperature and pressure, it has what? Contain equal number of molecules. So this is what? One volume. Definitely we will have what? One molecule of the same gas, as long as temperature and pressure are constant. Now we also add that one volume of chlorine, right? We also add that one volume of chlorine was going to combine with hydrogen. So it means that one volume of chlorine will also contain what? Will also contain what? One molecule of what? Of chlorine gas. Now, from our normal knowledge of electronic configuration and the basics of chemistry, we know that all gases, right? We know that what? We know that all gases, so this is a note. This is a note that we are meant to take note of. We know that all gases are what? Are diatomic, except the noble gases, that's except gases that are under the group O of the periodic table except the noble gases. And so we have that hydrogen and chlorine are not noble gases, right? They are not what? They are not noble gases. So it simply means that one molecule of hydrogen, will have what? Will be diatomic. Diatomic means having what? Two atoms. This will also apply to what? To chlorine. So it means one molecule of chlorine will also have what? Will also what? Contain two atoms. So now, since we have been able to establish this, we now have that. How can we now conclude that one volume of hydrogen from the question and combined with one volume of chlorine to give what? Two volumes of hydrogen? How do we conclude on this? So it simply means that if one molecule of hydrogen contained two atoms of hydrogen, and one molecule of chlorine also contained what? Two atoms of chlorine. Now, how many atoms will be in one molecule of hydrogen chloride? Now, how do we arrive at this? Remember that the question we had was two volumes of hydrogen, right? Of hydrogen chloride. Two volumes of hydrogen chloride came from what? One volume of hydrogen and one volume of what? Of chlorine. Now, one volume of hydrogen chloride will therefore contain what? It is now like a division, means we have divided it. We will therefore now contain what? One atom of H, and also one atom of what? Chlorine. Now, remember we had two volumes of HCl coming from one molecule of H, which is the same thing as one volume of H, and this it also came from this, and one molecule of chlorine gas. Now it simply means that for us, remember that one molecule of H of hydrogen gas, I think is much more better this way. If I write it this way, contains what? Contains two atoms of what? H. So the same way as this, we have that one mole of chlorine gas. We also have what? We also have two atoms of what? Of chlorine. Now, if we have this as the standard, it simply means that for us to have what? For us to have one mole, now one volume of the product of what? Of HCl. It simply means that it will only come when we can only be able to get one volume, which is one molecule of HCl, when we have what? When we have one atom of what? When we have one atom H, which is hydrogen, and what? And chlorine. So it simply means that we can conclude that the empirical formula that will come from the combination of one atom, which is H here, gas, plus what? Cl gas, giving us HCl. Hydrogen chloride is also a gas. Now it simply means that for us to get one volume, whenever you have chemical species written this way, that we don't have any number or coefficient just behind the element, it means that it will have just one of that. So it means we have one of hydrogen, and we also have one of chlorine here, and we also have one of what? Hydrogen chloride here. So it simply means that all these now will give us what? Will give us one of hydrogen plus one of chlorine will give us what? One of what? Of hydrogen chloride. But however, it is much more standard, since we know that hydrogen is diatomic, where we'll be written this way: H2 gas. It is much more standard if it is written this way: H2 gas plus what? Cl2, because we said these gases are diatomic, so we have it as giving us what? 2 of what? HCl. So it simply means that the empirical formula simply means the most simplest formula of hydrogen chloride will be what? Will be HCl. Quickly, let's look at another example. For proper understanding. Now here we have 3 volumes so we have three volumes of hydrogen now combines with now 3 volumes of hydrogen combines with one molecule or I can say one volume. The question says one volume of nitrogen question says one volume of nitrogen to form two volumes of ammonia. Now ammonia, as you all know, ammonia has the chemical formula of NH3. But now, how do we predict we are asked to predict the empirical formula of what? Of ammonia using what? Using the Avogadros Law. So now let's begin. As we said earlier, that the Avogadros Law states that our volume is equal to what? The number of molecules. And it was stated in the question that we had what? We had 3 volumes of hydrogen, right? So it means that 3 volumes of H simply means I am having 3 what? 3 molecules of what? Of H. I remember that hydrogen is what? Hydrogen is diatomic. So it simply means that 1 mole it simply means that 1 mole of what, of hydrogen gas is going to be equal to what, it's going to mean I am having 2 atoms of H. So we can therefore conclude that 3 volumes of H will mean I am having what, 6 what, will mean I am having 6 atoms of what, of hydrogen. I guess we are following. So quickly, we can also, since we are having a 1 volume of hydrogen as stated in the question, 1 volume of nitrogen, remember that nitrogen is also a gas, so we can say that according to Avogadros law, 1 volume of nitrogen means the same as what, as 1 molecule, same as what, as 1 molecule of what, of nitrogen gas. Remember that nitrogen is diatomic, as I said, so it means that 1 mole of what, of N2 gas, of nitrogen gas, will mean what, will mean it is what, 2 atoms of nitrogen. Sorry, there's no need to add gas there anymore. So we have what, 2 atoms of nitrogen. Now combining this, combining 3 atoms, combining 3 atoms of 3 volumes rather of hydrogen and 1 volume of this. Now let's break it down to the atom level. Breaking it down to the atom level, it simply means that our 2 molecules of ammonia, which is the product, remember it was given as 2 volumes, so we can say 2 molecules of NH3 will therefore now contain what, will contain what, 6 atoms of, it means it contains 6 atoms of what, H, and what, and 2 atoms of what, of N. Now empirical formula simply means the what, the simplest, simply means the simplest formula. Since we are having 2 NH3 being comprised of 6 atoms of what, of H, and what, and 2 atoms of what, of nitrogen, right? Now how many therefore will now be in 1 molecule or 1 volume? 1 molecule or 1 volume of what, of ammonia, which is NH3, we will now contain what, it means we are going to divide all through by 2. Since we have broken ammonia here divided by 2 to get 1, it simply means that the 6 atoms of hydrogen here will be divided by 2, so we will therefore have 1 molecule or 1 volume of ammonia to contain what, 6 divided by 2 will give us what, will give us 3 atoms of what, of hydrogen, and our 2 atoms of nitrogen here divided by 2 will give us what, will give us 1 atom of what, of nitrogen. So it simply means that we have 1 atom of what, 1 atom of it simply means we have 1 atom of what, of nitrogen. Hence we can conclude that the empirical formula which is the simplest formula of ammonia, will be equal to what? Will be equal to what? NH3. That means we have what? We simply means we have one atom of N, and we also have what? 3 atoms of hydrogen. So we would like to have your feedback and comments on this particular video, just in case you didn't get some things right, or you feel there's a better way we can get this knowledge across to you. You can drop your comments in the comment section, and just in case, don't forget to like, subscribe, and share this video, and also hit the notification button so that you can also get good content just like this whenever we make more videos. So thank you.